In this video, we'll be talking about a summary of all the concepts. Just go over everything all at once so that you are even more familiar with them. And in the next video, we'll be building a small application which will be putting all of these concepts together to even further solidify the lessons learned. First, let's talk about a class. A class is the building block in object-oriented programming, and we can create one with the reserved keyword class, like we have one right here. So we have the reserved keyword class, and then we have the name of the class, which can be anything we choose it to be. A class is basically a blueprint, which we use in order to create objects. And from one blueprint, we can create as many objects as we want. So we have one class, and then we can as many objects from that as we want. If we take a look at here, I'm just going to copy and paste this real quick. I won't be changing any of the names, just want to quickly up the name or change the name so that it can work. And so here we have the same class, but we have a different object, right? So we instantiate our class in both ways, the same class, but out of that class instantiation, a different object comes out. So we have the variable on the left side with the type of the class that we are instantiating. And then on the right side, we have the instantiation of the class, which then gives us an object and puts it into this variable. So this is a different object and this is a different object, but they both came from the same class. Okay. So the way we make new objects is through a process of instantiating a class. And as you saw here, we instantiate a class by using the reserved keyword new. So you use the new reserved keyword, and that's how you instantiate a class, which then takes that and puts a new object into the variable on the left side. So that's how that process happens. Now let's talk about abstract classes. Abstract classes are classes which cannot be instantiated the way we are instantiating this concrete retail salesperson class or concrete car salesman class. However, here we have our salesman abstract class. And so, as I was saying, an abstract class is basically a base class, or in other words, they are allowing us to unify functionality in one class. We then inherit from the abstract class to gain the base functionality. In abstract classes, we can have abstract members such as abstract properties or methods which need to be overridden and classes inheriting from them by using the override reserved keyword. They can also have virtual members, which means they already have a definition, but they can also be overridden using the override reserved keyword. So as mentioned here, I have some abstract members, and those abstract members get overridden in the retail salesperson, for example. So we override them using the override reserved keyword, and we have their own specific definitions. Now, I don't have any virtual members, but from the previous examples, you remember how a virtual member on the abstract class was able to have its own definition, but then we had a choice to whether override that or leave it the way it was as it was on the base class. So it's our choice, but it gives us an opportunity to be able to override that. So the class inheriting from another class is called a child class or a subclass. And a class being inherited from is called a parent class or base class. So in this case, this is our parent or base class, and our retail salesperson and car salesman are child classes or subclasses. So when we are in the child class, we can refer to the base class by using the reserved keyword base, such as we have it here, and we're referring to the base class's constructor using the base reserved keyword. Also in the child class, we can refer to itself by using the reserved keyword this. So for example, if I had another parameter coming in, such as int age, as we've seen that before, private int age, and I'm going to just say this in the constructor, say age. As you can see, we have access to it. And what this says is that this, meaning car salesman's age, is equal to the age that's coming down from the parameters. Okay, so that's what this reserved keyword allows us to do. It just allows us to refer to the class that we are currently in. So I'll take that out and we can move on. So interfaces, on the other hand, in C# contain no declarations whatsoever. We already have one called self-developing. So these have no declarations at all. And they can only have methods and properties. In this case, I only have a method, which are completely abstract and need to be implemented in the child classes. So our web developer actually has a self-developing interface that it's implementing. And so it needs to have a develop method with the same signature that we see on self-developing interface. So it's void develop. And if we come here, void develop, it's public by default, and it has its own definition. So we need to define that. We need to basically implement that class or property that we get from an interface in our child class. That is how interfaces work. They don't have any definition of their own. We have to give it a definition when we inherit from them or when we implement them. So one quick convention also, we inherit from classes, but we implement an interface. The way it's done is exactly the same. We use a colon, but we just use different words. And that's just a convention, quick convention to know. So now the difference between abstract classes and interfaces. Abstract classes are for unifying relevant group of classes, and interfaces are there to unify unrelated group of classes. Now you can inherit from one class, but you can implement many interfaces, since C# does not allow you to inherit from multiple classes, and interfaces were introduced to get around that problem. Now, as you can see, we have a developer, a base class is an abstract class, and we have a self-developing interface. Now check it out. Imagine if I said that my web developer can also have salesmanship abilities, right? If I take that out and I say salesman, this would not work. Why? Because it says cannot have multiple base classes. C# is forbidding us to have multiple inheritance when it comes to classes. But if we put back the interface, it can have one base class and it can have many interfaces. We just happen to have only one, but if we wanted it to have more, we would just have comma and then, put the next interface in line. So that's one of the key things to remember in C# object-oriented programming is that we do not have multiple inheritance. Let's now talk about the 4 pillars of object-oriented programming, which are inheritance, polymorphism, which has 2 types, encapsulation and abstraction. Inheritance is done through using a colon symbol. So just the way we have it right here. So we use the colon symbol in order to perform inheritance. You can have the class on the left of the colon right here, which is trying to inherit from the class that is located on the right of the colon. So, this is the base class and it's also implementing this interface. So anything that's on the right, it's inheriting or implementing. But what's on the left, which is usually going to be, not usually, but always going to be one class, that is going to either inherit from one class or inherit from one class and many interfaces, or just one interface or many interfaces. So those are the possibilities that we have. So inheritance allows you to gain access to the attributes and behavior of an existing class. So in our class, car salesman, we needed the base functionality from the salesman base class. We used inheritance to gain access to those attributes and behavior. So car salesman and retail salesperson needed some base functionality, and we inherited that by using a colon from the salesman base class, abstract class, such as the property, the way it's calculating that, the constructor, the way it's ordering the cell concrete method. We got the concrete method cell from that. So there's a few things that we inherited down from an existing class. That's what inheritance allows us to do. Polymorphism is a technique in which the same component can have different behaviors. We have dynamic polymorphism and static polymorphism. In dynamic polymorphism, we have the same method signature on 2 child classes which inherit from the same base class. So in this case, we have the engage, which is only on the base class, right? And it has the same signature, but in car salesman and retail salesperson, you can see, so if we go back once again, you see engage, right? It's the same thing, but it has different behavior on car salesman right here. And, in this case, it says hello, but I could just said as simply, I could have just said hi on this one, and retail salesperson says hello. So it's a different behavior, right? We just happen to have them the same, but it doesn't have to be the same. We can completely differentiate the behavior, though it is basically the same method, but it's being defined differently in 2 child classes. So that's our dynamic polymorphism. So once again, in dynamic polymorphism, we have the same method signature on 2 child classes which inherit from the same base class, but those methods have different behaviors and we define them separately, just the way you saw it a few seconds ago. So the method is the component in this scenario, which can act differently depending on how many child classes inherit that same method and define it on their own. Dynamic polymorphism also happens on a class level, so we need abstract classes and interfaces in order to perform that, as you've already seen. So it happens on a class level, meaning that this class says, I will be, in this case, engage or any one of the methods that's abstract. It says that, hey, I am here on this class, but I will behave differently on child classes. So that's why we need an abstract class, or we need an interface, just the way you've seen before. Develop also has different behavior. It has the same signature on the parent, but on the child, it has a different definition. So it acts differently on other classes. Static polymorphism, on the other hand, allows us to let the same method in the same class have different behavior. So you have a method code, let's say, in our developer right here, right? We have code method, but it behaves differently. And what makes it behave differently is the fact that it takes in different parameters. So that's static polymorphism. Either different amount of parameters, different type of parameters, or parameters which are ordered differently from one another. In this case, we have different amounts. So this one has none, this one has one, this one has two. But we could have also had same amount, different types. So it could have just been, same amount, but different types. So this one is int. This would have worked as well. Or they're ordered differently, meaning that, you can have two parameters, right? And same types. One is int, one is string, let's say. Bring it back. But they're ordered differently. Though this is not recommended because it just makes your code a lot more confusing. So you just want to keep it either differentiated between the amount of parameters or types of parameters. It's much more intuitive that way. Now, encapsulation is the process of hiding our implementation. I'll go back to the salesman, and we use access specifiers in order to do so. We have public, private, protected. Public, as you've already found out, allows us to share the attributes or behavior of the class with any other class, within or outside of the class. Private keeps the class members only accessible from within the class. So our fields right here. Protected, on the other hand, says that the members that are denoted as protected can be accessed only from the classes that inherit from the class that they're in. So in this case, salesman will give access only to retail salesperson and car salesman, which is what we have right here. Anything else won't have access to these methods because they're protected. Lastly, abstraction happens as a result of encapsulation. Encapsulation in and of itself is a blind process. So we go back to salesman, it's just a blind process of hiding certain things and showing others. And that's all it is. However, the reason as to why you are hiding or showing things is abstraction. You hide things because you want to only show things to the end user that are relevant to them. And you want to abstract away the implementation details, such as these guys, that the user doesn't much care about in general. And it makes the usability of your class much more intuitive and less error prone when it's used by others. So that is all. I hope this was a good refresher for you. In the next video, we'll be building a small application which is going to put all these concepts together in a code so that you can see how they all fit together.